Hello. Yes, good morning and welcome to this demonstration of IoT. Here I'm going to introduce you to the basics of Internet of Things. I hope I'm audible. Okay, so what is IoT actually? See, when it comes to IoT, it is defined as the interconnection of smart objects, and these objects are capable to communicate with each other. And basically, IoT is all about making the machines or devices or things smart and making them communication enabled. So what we are going to discuss today is what is IoT, the different types of IoT devices, the components that we use to design IoT devices like microcontroller units, communication modules, the protocols that we need to implement in the IoT devices to make them enable to talk to each other. Connecting the IoT devices to cloud so that we can capture the sensor data and upload it to the cloud for further like analyzing it and deriving the results out of it to make the processes, let's say, or to help businesses run efficiently. In the next step, we are going to talk about the different types of programming languages that we use to program IoT devices. I'm also going to talk about a few popular operating systems used on IoT devices, and we'll talk about the IDEs or programming tools, integrated development environments, that is used to write the program, to check the programs, to compile the programs, and finally to upload the programs on the small single chip computers or microcontrollers. And we are going to talk about different use cases and the opportunities being created by IoT. Okay. So let's move to the next slide. The point is, everyone is talking about IoT, but the point is why we are talking about IoT at this time, and why is this the perfect time to talk about IoT? Actually, when it comes to IoT, IoT is not just a technology; it's an interdisciplinary technology which has applications in almost all the areas of our daily life, or let's say businesses. See, we can utilize this technology to make our lives simpler, as well as let's say we can run our daily activities in a more efficient way, as well as it is equally beneficial for the industry as well as for the businesses. According to Mr. John Chambers, the CEO of Cisco, the Internet of Everything will be 5 to 10 times more impactful in the next decade than the entire Internet has been to date. It means Internet has been proved as a very impactful technology, and now Internet of Things is going to be a more impactful technology than the Internet. Why is it so? Because Internet IoT is also being called the fourth industrial revolution. See, it's going to touch almost all the spheres, all the aspects of our lives. And in today's time, we are surrounded by thousands of smart devices, and these smart devices are making our life easier. The point is, what do you mean by smart things when it comes to technical domain? The smart thing is a thing which can think. Now, what do we need to make a thing think? Obviously, to make any device or any machine or anything smart, what do we need to do? We need to embed a small computer inside it, and this small computer is going to work like the brain, the same thing that our brain does in our body. Additional to this, apart from embedding a small computer into our devices, we also need to embed sensors and actuators, plus communication modules to make our device able to talk to each other as well as to other devices present on the internet. So sensing is the first thing that we need to embed in our devices. The sensors are small electronic components which acts like eyes and ears of IoT devices. The computers acts like brain of an IoT device, and these computers are actually not black boxes anymore. These computers, all the four building blocks that we need to build computer are available in the form of single chips now. The next thing that we need in the devices is some kind of actuation capability so that our devices can perform mechanical actions, as well as the communication capabilities to be like integrated in our devices. So we need to embed these four basic capabilities to design an IoT device. Now, next slide, let's understand what do you mean by computer. So when it comes to computer, a computer is defined as a programmable electronic system. System means a combination of different components, and these components are like independent to each other, but when they are connected together, they are going to work in sync to perform a specific task. So just like a car is a mechanical system where different mechanical components are like integrated or connected together, and the car is performing a specific task of transporting us from one place to another place. So the computer is also a system. This system is made of four basic components. We need a program memory to store our programs and data. We need a microprocessor to execute, to run these programs. We need RAM to store the runtime data, whatever is being collected through input-output devices. And we need a few special logic circuits to connect the input-output devices with the computers, like keyboard, mouse, and sensors and motors, etc. So nowadays, like VLSI technology, very large scale integration technology, has made it possible to integrate, to fabricate all these logic circuits in the form of a single chip. So now all this logic circuit comes fabricated in the form of a single chip, and these single chip computers are called microcontrollers. So the computers that we need to embed into our devices are not actually big boxes, but this small single chip computers. And these single chip computers comes with different types of capabilities. So these are a few examples of single chip computer from very popular company Atmel. These are different families from Atmel: 80 Tiny, 80 Mega, 80 X Mega, and the 32-bit microcontrollers based on ARM, the most popular RISC architecture. Now, when it comes to we don't generally see these single chip computers around us. The reason is these single chip computers comes embedded into different things. So, like your mobile phone or your smart wristwatch or a smart car or a smart washing machine or ACs or traffic signals or ATM machines. And these are the examples of embedded systems. And an embedded system is defined as a system which has a computer embedded into it. So there are thousands. We are surrounded by like thousands and thousands of systems in which this single chip computers are embedded. And right now, there is a $400 billion demand. There is demand of around $400 billion of electronic products in India. And currently, the local production is limited to 100 billion only. This is why Government of India is trying to promote this electronic system design and manufacturing ESDM sector at very high level. And it is expected that this ESDM sector, which is part of Make in India campaign of Government of India, is going to generate somewhere around 28 million jobs in next 5 years by 2020. So government is planning for a zero import policies, and government is planning to manufacture most of the electronic systems or smart systems or embedded systems locally in India. And to achieve its goal, government has planned around 200 manufacturing clusters all over India to manufacture this electronic systems locally. Okay, so there is a huge market of embedded systems in India at present, as well as we are going to witness rapid growth in this area. Okay, now when it comes to designing these embedded systems, when it comes to writing programs for these small chip computers, like most of times it is a challenging task. The reason is it comes in the form of small ICs, and it needs lots of supporting electronics to program this single chip computers. And this is the reason why there are many groups, research groups, and companies like multinational companies who have launched prototyping boards in the market. And this prototyping boards comes with the single chip computers mounted on the top of them, and all the supporting electronics is also available on the same prototyping or development board. Now this prototyping board has made it simpler or easier to program these single chip computers. So what we are going to get on this prototyping board is all the supporting components like power supply, the crystal oscillator, the USB connection, with the help of which we can connect it to the computer and download or upload the program directly onto this small chip computers. Arduino, and with its many variants, ranging from Pro Mini or Lillipad to Uno or Yun or Mega, also more, Arduino is one of the very popular open source platform which can be used to perform the experiments experiments to design in IoT devices. It's an open source technology, that is why it is gaining the popularity, and most of the multinational companies are using Arduino as a prototyping board to design IoT devices. The second very popular the prototyping board is Raspberry Pi, and Raspberry Pi is actually comes with in space. Let's say it's a single board computer, and actually it's a OS based computer, and there is a special optimized distribution of Linux called Debian. Debian has been further optimized in the form of Raspbian to run on Raspberry Pi. And now Microsoft has also extended its support for the Raspberry Pi platform, and the new Pi 2 and Pi 3 Raspberry Pi boards are going to accommodate, or let's say are capable of running Windows 10 operating system. So now Windows 10 as well as Linux, both the single chip computer or single board computers are capable of running both the operating systems, Windows 10 as well as the Raspbian, which is a version of Linux. What do we get here is that we can use this Raspberry Pi board either as a desktop, or we can also use this Raspberry Pi board as a gateway or a web server in our IoT networks. Okay. The beauty of both this platform is that this Arduino, the microcontroller on the top of this Arduino, is actually a 16 megahertz microcontroller. This speed of this microcontroller is 16 megahertz, and as you can see here, this microcontroller, this single small chip, has 256 kilobyte of ROM inside it, as well as 8 kilobyte of RAM. Plus, there are some around 86 pins to connect our input output devices. Now, using this small boards, or let's say to perform some, let's say to build small student level projects or small robots, is actually underutilizing their capabilities. These boards are very much capable to design high-end IoT devices. As well as when it comes to Raspberry Pi, using Raspberry Pi as a desktop computer is again underutilizing its capabilities. The reason is Raspberry Pi is based on a very popular and high-end architecture called RISC, and the processor that is being used on the Raspberry Pi prototyping board is ARM Cortex processor. And these ARM processors are the leading processor in the right now in the computer industry. This Raspberry Pi also comes with many GPIO capabilities. There are more than there is a 40-pin header on the top of this Raspberry Pi board, and this out of these 40 pins, 26 pins are actually GPIOs. GPIOs stand for general purpose input output. So with the help of this GPIOs, we can interface most of the low-level peripherals like LEDs, switches, motors, sensors with our Raspberry Pi board and control them. At the same time, it comes with many specialized input-output protocols or communication capabilities available on these pins. As you can see here, it supports I2C. I2C stands for Inter-Integrated Communication Protocol, and this I2C protocol was developed by Philips. So I2C bus, it's a two-wire communication technologies, and with the help of only two wire, we can connect 112 slave devices with Raspberry Pi. Means, with the help of only two wires, we can connect 112 slave devices with the Raspberry Pi. Okay. The second communication protocol available on this pin is SPI. SPI stands for Serial Peripheral Interface, and with the help of this Serial Peripheral Interface too, we can interface more than one devices, or more than one slave devices with the Raspberry Pi board. So both of these protocols, I2C as well as SPI. SPI was developed by Motorola. So I2C as well as SPI, as well as there is one more serial communication protocol available over here, which is called USART. So SPI and I2C both are actually synchronous serial communication buses. So the serial communication that is being done by using I2C and SPI is synchronous communication, synchronous serial communication. So these are the two most popular protocols, and we can use these protocols to connect many devices to Raspberry Pi, as well as we can connect devices to each other by using these protocols. So this is one way of implementing M2M, or machine-to-machine communication, or wired machine-to-machine communication. Now, by using this Arduino and Raspberry Pi, we can build we can make many things smart. Let's say starting from our mailbox to, let's say we can design a fire alarm, or we can control the temperature of your house, or we can monitor the garage door, or most of the end devices, washing machines, ACs, refrigerators are being used this type.
You hear me now, Arjun? Okay. Sorry about the response. Actually, the headphones stopped working. Okay. So when it comes to selection of this microcontroller platforms, what you need to check is their efficiency, energy efficiency, the software ecosystem available to reduce the development time, as well as the scalability of the available variants. Plus, there should be a good mix of input-output interfaces, like the microcontroller must be capable of accepting analog signals as well as digital signals, plus the solution must be cost effective so that the end device is also going to be cost effective as well as economical. The solution must be like reliable as well as secure. So both of these platforms, which are actually an entry level platform, there are high level platforms too. I'm going to show you a few of the platforms which are actually being used at high level, and this Raspberry Pi and Arduinos are actually entry level platforms which can be utilized to design and test our IoT solutions. Okay, so basically these are actually learning platforms, not actually product designing platforms, you can say. Okay, so this is the way we can make any system smart, or we can make any system intelligent by embedding the single chip computers uh, into devices. But the point is, what is new? So, what is new now is that most of the wireless technologies, which were previously like available in the form of large electronic systems, separate large electronic systems, are available in the form of small chips. And this wireless communication protocols, which are actually comes embedded into small form factors or small ICs, are actually now runs at very low power. So they are going to consume less power if we integrate it into our devices. So the wireless communication technologies available to integrate with our devices are ranging from Bluetooth to WiMAX, are actually divided into, based on their applications, are divided into different classes or different categories, you can say. When it comes to short distance communication, the dominating technology is Bluetooth. Here, the PAN stands for Private Personal Area Network. So, Bluetooth as well as Zigbee and Wi-Fi. These are the three most popular wireless technology right now. All these three technologies were developed by IEEE, and it belongs to IEEE's 802 family standards. Wi-Fi is actually 802.11 IEEE standard, and Bluetooth and Zigbee, which are actually private personal area network technologies. Zigbee is actually it is used in PAN as well as in LANs. So Zigbee and Bluetooth both falls under 802.15 IEEE standard. So Bluetooth is a cable replacement technology, and in today's time, almost 65% devices, smart devices, are using Bluetooth protocols to talk to each other. For example, in our mobile phones, Bluetooth comes inbuilt, and mobile phones can share files with each other by using this wireless communication technology called Bluetooth. Okay, Bluetooth has been further optimized for IoT devices, and the new version of Bluetooth, which is actually Bluetooth 4.0, or also called Bluetooth Smart, is optimized for IoT networks or IoT devices, and it's going to consume less power. That is why it is called Bluetooth Low Energy Protocol. Now, when it comes to long distance communication, Wi-Fi is the dominating technology, and nowadays, like Wi-Fi is a synonym of internet, and but Wi-Fi can also be used in the devices to uh, connect to these devices each other in the form of a local area network. Uh, the other technologies like 6-low-PAN, which runs on the top of Zigbee, as well as RFID and NFC, are equally popular and equally being used in most of the IoT devices. Okay. So actually, this Bluetooth and Wi-Fi, as I mentioned earlier, this Bluetooth and Wi-Fi protocols are available in the form of small integrated circuits or chips, and this uh, both of these modules shown here are actually UART compatible or serial communication compatible, and this is the reason why we can easily integrate it with Arduino as well as Raspberry Pi. So with the Bluetooth and Wi-Fi, these two communication protocols are going to be like discussed in this IoT training program, and as well as we are also going to discuss the other supporting IoT protocols in this training program. Okay, now let's come to the third step of our presentation, that is the internet. See, when it comes to internet is is an interconnection of billions of computers worldwide. Until that, we have been using this large network of computers for information distribution, information sharing, as well as for collaboration and interaction. So internet is the backbone of today's communication technology, and most of people-to-people communication is being managed by the internet network. But the same network, which is actually very strong network and can be utilized for machine-to-machine communication or M2M communication. This is machines can, if machine can talk to each other uh, uh, using wired communication or wireless communication, then it is also possible to connect this smart systems or machines or devices or things to the internet by using some kind of communication mechanism. So if we connect our devices to internet, this is what we call IoT. IoT is an interconnection of billions of smart devices which are like getting connected with the internet through wireless communication facilities. And once the devices are connected to this internet, the possibilities are almost unlimited. So let us understand what is Internet of Things. So now the proper definition of Internet of Things is that it's a worldwide network of interconnected objects, uniquely addressable based on standard communication protocols. What we need to notice here are two things. First thing is uniquely addressable, and the second part is standard communication protocol. So whenever we are connecting our devices, our things to the internet, on the internet, every system has a unique identity, so that it can be addressed uniquely, and this unique identity is called IP address. Uh, we have been using an IP address which is actually a 32-bit IP address, or called IPv4. With the help of 32-bit IP address, we can connect maximum to the power 32 devices to the internet, and this is the limitation. Actually, it is expected that by 2020, the number of smart things connected to internet is going to grow to 75 billion. So it means we are expecting 75 billion devices connected to internet by 2020, and it's going to create a huge opportunity, as well as it is going to create a challenge when it comes to addressing these devices uniquely. So this is why a new IP protocol has been developed, and the length of this new IPv6 protocol, we call it IPv6 version 6 protocol. The length of IPv6 address is 128 bit. So with the help of this 128-bit address, now it is possible to connect 3.4 cross 10 to the power 38 devices to internet. So IPv6 is a protocol which is going to solve the problem of addressing this a huge number of devices going to be connected to the internet. Now, if you look at the roadmap of technologies, uh, there was an era called PC era. In PC era, like personal computers were being used by the businesses to store the information, to process the information, and to distribute the information. And at that time, like putting the users of this technology, PCs, personal computers, were humans. And then came the internet era, and the internet era was the era of information exchange. So in the internet era, the number of users, number of technology users grew to 1 billion. And then came the mobile era. In the mobile era, the technology reached to more than 5 billion people. Right now, there are more than 5 billion users, mobile users, all around the world. But if you look at this IoT era, the era that is going to be commencing now, the IoT era, in the IoT era, the users are not actually humans. The users of technology are machines. That means there will be less and less human intervention, and more tasks, or more and more work will be managed by the technology or the machines on themselves. It means these machines are going to be capable enough to manage everything automatically, and we call them autonomous systems. So it is expected that this 50 billion or 75 billion devices, whatever the numbers there, these devices are going to communicate to each other. These devices are going to share lots of information to each other, and these devices are going to manage almost everything automatically. So this is the basic concept behind Internet of Things, or IoT. Now looking at the second point that was mentioned in that slide, the definition of IoT was the standard communication protocols. So when it comes to these devices, IoT devices, see, when two systems are talking to each other, there should be a common language. And the common language most of the systems speak on the internet is called TCP/IP. TCP stands for Transport Control Protocol. IP is the Internet Protocol. So TCP/IP is one of the legacy communication protocol used on the internet. But when it comes to this IoT devices, as we already discussed in previous slides, that IoT devices, most of the IoT devices runs on batteries. The primary source of power of these IoT devices is battery. So the battery lifetime is a major challenge and the primary concern of most of the IoT designers. So to make the battery lifetime longer, or let's say to reduce the power consumption, we need optimized protocols for IoT devices. This optimized protocols have to be lightweight, and there should be less complex formalities when it comes to connect the devices to each other, or when it comes to interchange of the information between devices. There are different bodies around. IEEE is one of the standard regulatory body, as well as IETF. IETF stands for Internet Engineering Task Force. So IETF and IEEE both have developed most of the protocols being used in the communication domain till date. But there is a new protocol which has been optimized by further to run on this IoT devices, is called MQTT. And this MQTT is actually developed by OSIS. So OSIS is another standard regulatory body which is developing communication protocols for IoT devices, and there are many more standard regulatory bodies. These regulatory bodies are writing standard languages for the IoT devices. If you look at the complete protocol stack for IoT devices as well as other systems running on the internet, there are many thousands of protocols at the lowest level, at the physical level. When it comes to connecting devices to each other, the options are like Wi-Fi, Ethernet, or 2G, 3G, or now we are talking about 4G or LTE, as well as WiMAX. These are called physical layer protocols. To manage the transport and addressing, there are TCP/IP protocol is being used, and this protocol there is right now there is no alternative of TCP/IP. But when it comes to the topmost level, the application level, most of the companies are trying their proprietary communication protocols at this level, and the one of the very standard protocol that is being used by the web browsers to interchange information with the web servers is HTTP. So MQTT and CoAP, these are the two lightweight protocols designed to handle the application layer task in the new IoT protocol model. See, like we can play around only like at the physical level or at the application level when it comes to designing IoT devices. TCP/IP is one of the standard protocols, so we cannot. There is no alternative of TCP/IP right now. But UDP, which is actually when it comes to the to manage the transport layer tasks. TCP and UDP, these are the two protocols available at the transport level. TCP is connection oriented protocol. It is very reliable protocol. UDP is a connectionless protocol. It is not that much reliable, but it is simpler when compared to TCP. It means UDP is a lightweight protocol when we compare it with TCP. So UDP is recently gaining popularity in the IoT networks. So this is the complete protocol stack of IoT devices or IoT networks, which are being used in most of the implementation nowadays. We'll talk more about like practical implementation of MQTT as well as HTTP, Wi-Fi, Bluetooth, Zigbee, and 6LoWPAN in this training program. Okay. Now, when it comes to making the devices smart and connecting it to internet, this we can achieve with the help of all those microcontrollers as well as communication modules. Okay, but what are we going to do once these devices are connected to internet? Actually, the cloud computing comes into the picture at this level. See, cloud computing is actually on-demand delivery of IT resources, infrastructure, as well as application via internet with pay-as-you-go pricing. Now, when it comes to, let's say, if we talk about a use case of IoT, let's say smart city is one of the very popular use case of IoT. So let's look at how this smart city are being implemented. So in a smart city, like energy, utility, vehicle, transit, and public safety, everything is going to be managed by the wireless networks. So this wireless wireless sensors actually, these wireless sensors modules are being deployed at many places in a smart city. So there are thousands and thousands of wireless sensors modules deployed all around the city, and these wireless sensors modules are capturing the real-time environmental data and sending it to a central server. As this central server is actually called, this central server is actually established on the internet, and this central server is called cloud. This central server has large amount of storage space, as well as it is capable of performing high-speed computing. So the leveraging the benefits of cloud, and actually why do we need cloud computing, and or what is the role of cloud in IoT? Let us understand it through this example. So in this example, it is an example of human body. In human body, like the eyes and ears and the skin as X-like sensors, and the data collected by these sensors is related to the brain. And the human brain is actually capable of collecting this data and processing or analyzing it, and based on the information hidden in those data, the brain derives the results and then initiate the mechanical actions to perform physical tasks. Okay. So, in the similar fashion, in a smart city project or any IoT implementation, the data being collected from the sensors is being uploaded on the cloud, and lots of analysis or analytics is being done on the cloud to derive valuable results out of the collected data, and then these results are being used to initiate physical actions to control devices, as well as this analytical results of this analytics is also going to help the businesses and the organizations to take business related strategic decisions. So the cloud is actually the infrastructural support for our IoT network, and this is the reason why, like we are connecting most of our devices to the cloud. The second benefit of using cloud is that when it comes to putting computing load on our device is going to consume more power. The reason is the power consumed by a processor is proportional to its operating frequency. So if you put more computing load on our end devices, it means it is going to reduce the battery lifetime. Why? Because the device is going to consume more power. So the strategy is that let us put less computing load on the end devices and more computing load on the cloud. And the only sensing and actuation is being managed by our device, but computing is not being done on the device, but rather, like computing is done on the cloud. Now, to make this strategy successful, what we need is a very high-speed internet highway or internet backbone, and this is where lots of efforts are being made to deploy high-speed internet facilities or high-speed internet networks all around the country. So once, in this training program, we are going to teach how to develop smart devices, how to integrate, how to connect this smart devices to the cloud, to share the storage of data, as well as to share the computing load. Okay. Now, moving to the next slide, this slide shows a complete implementation of IoT-enabled IoT system. As you can see here, the end devices are actually running on 8-bit microcontrollers. So let's say the Arduino platform is one of the very good example of 8-bit microcontrollers. So most of the end devices actually run on 8-bit microcontroller. The reason is same, to reduce the power consumption, because this end devices are not going to manage lots of computing work, but their job is just to collect data and send this data to the cloud, and to generate mechanical actions when there is a signal coming from the cloud or coming from the end user. So this end devices mostly are based on 8-bit microcontrollers, and as I already explained that the utility of Raspberry Pi or any other platform. Now Galileo is Intel Galileo is another a learning platform which comes with lots of onboard resources. So Raspberry Pi is a very good prototyping board to be used as a web server to connect our devices to internet. So this Raspberry Pi is going to act like a gateway, which will take the data from all the devices in a local area network, and then connect these devices to the internet, and it is going to work like a broker. Now, once it comes on the internet, we can connect this our network to a larger network, where this cloud infrastructure is available. And on this cloud infrastructure, the data is being analyzed by the analytical tools. And finally, the end user is also connected to this cloud to gather, or let's say, to utilize the analytical results. Okay. Uh, ThinkSpeak is one of the cloud, and there are many other alternatives. There are many other like cloud platforms offering their services free of cost to the students, to learners, and to hobbyists, as well as to research professionals in the field of IoT. So ThinkSpeak is one of the very popular cloud platform where we can upload the data and we can visualize data in the form of graphs. Uh, now, when it comes to this data we are collected from the IoT devices, we call it big data. The reason being is this the data being generated by the machines is huge in volume, in the let's say in the range of petabytes. So petabyte is equal to the 1,000 terabytes. So now the data being generated by the devices is in the form of, let's say, huge volume of petabytes of data. Second thing, we need this cloud, the computer available, the server running in the form of cloud to collect and to analyze and to generate actions in real time. So what we need is that our server must be capable of handling large amount of data in almost no time. And the third challenge we are facing here is that the data being collected from the devices are of different types. This data is called unstructured data. So the data, it could be an image or an ECG signal coming from a healthcare system, or it could be any, an audio signal, or a web page, or anything. So data coming from the devices are actually of different types. So we want our cloud infrastructure to store this large amount of data, which is actually now unstructured, and process this data in real time to generate real time actions or real time uh, results. So looking at these three aspects of demands of IoT networks, it's going to be a bit challenging, and this is why the companies are trying to find out special tools, special analytical tools to manage the data coming from the IoT devices. Now, when it comes to analytics, web analytics or mobile analytics is very different from the IoT analytics. When it comes to IoT analytics, these are three. The data coming from, let's say, an ERP solution, or a management information system from a company or from an organization is most of time structured. But the data coming from the IoT devices are actually of different types, and this is the reason why most of the conventional tools are not very much efficient when it comes to IoT analytics, and this is the reason why new tools are being deployed or developed to manage IoT analytics. Okay. So this big data coming from the devices has great potential, but it has to be processed efficiently by using optimized IoT analytics tools. Okay, so basically, like analytics is all about uh, analyzing the data sets to reveal the patterns, trends, and associations out of it. And as I already discussed, that the volume, variety, and velocity are the 3 points that we need to take care of when it comes to analyzing the IoT data. Okay. Now coming to the languages for IoT app developments, uh, the most popular language right now in the IoT domain is Python, according to one of the survey. Uh, but the JavaScript, or let's say Node.js, is also gaining the popularity. Okay, so the most basic language when it comes to program, microcontroller, the assembly and C language is the preferred language. The reason is both of these languages, assembly as well as C, supports procedure-oriented programming approach, and it's easy to write programs for systems with sequential behavior. And at the same time, assembly and C both are platform, sorry, resource efficient language. And as we already discussed, that this small chip or single chip computers or microcontrollers comes with limited resources on the chip. So we need efficient programming tools to write programs for this 8-bit microcontrollers. So assembly and C both are the preferred languages to write programs for microcontrollers. But when it comes to complex or sophisticated embedded systems, or the embedded systems being used as IoT devices nowadays, are actually complex environments. And assembly and C is not are not the suitable languages to write programs for these complex systems. Why? Because we need to go for a higher level approach called object oriented programming approach to develop software for complex devices or multi application devices. C++ or let's say Python or Java are the languages being used to write programs or softwares for high-end IoT devices. Out of these three competitors, Python is one of the very easy to learn language, and Python, it supports microcontroller programming. Like you can write the programs for microcontrollers by using Python, as well as you can also write analytic softwares by using Python. As well as Python has great capabilities to be used as a scripting language for the servers. So Python, which comes with more than 26,000 packages, inbuilt packages, and these packages comes with many modules with and thousands of methods which can be used, which can be utilized while writing the programs. Actually, this approach reduces the development time. So Python is an easy to learn language, and we can do many sorts of things. We can develop different types of applications ranging from microcontrollers to the cloud, and this is the reason why Python is the most popular language. Okay, but it has a drawback too. The reason is it's being an interpreted language. Python is a bit slower compared to other compiler-based languages. Uh, languages are like tools. The suitability of a particular language to develop a particular application depends on uh, our requirements. So almost Java, Python, and assembly and C. These are the four languages which are being used in the IoT implementation in today's time. So in our training programs, we'll discuss or we will write the practically the programs for IoT devices by using assembly, C, Python, as well as JavaScript. The Python is preferred language on Raspberry Pi, and the JavaScript as well as Node.js environment is the preferred environment for Intel Galileo. As I already mentioned, that Python has the is the good tool to write microcontroller-based programs as well as many other things. Okay. Now, when it comes to operating systems, the operating systems being used on IoT devices nowadays, Windows 10, or let's say Windows 10 as well as Brillo from Google. So Google has launched Brillo as the optimized operating system for IoT devices. When it comes to operating systems are the software which manages all the system level tasks on a computer system. And being a software, these operating systems also consume memory as well as the CPU time. So, as already mentioned, that the end devices are going to be the devices running on 8-bit microcontroller with limited resources. So we cannot afford heavyweight operating systems running on IoT devices, and this is the reason why the newer operating systems are coming in the size of kilobytes. So this Brillo is a cut down version of Android from Google, and Google through this Brillo is targeting the capturing IoT market in the similar fashion they captured the mobile market. The other popular operating system for IoT devices is Windows 10. Microsoft is pushing the Windows 10 to run on desktop and laptops as well as on IoT devices. So Windows 10 is like Microsoft has also extended the support for Pi platform, Raspberry Pi 2 as well as Pi 3 can run Windows 10 now. So Windows 10 is the second popular operating system for IoT devices. Third operating system popular is Linux. So Linux comes in the form of Raspbian for Raspberry Pi, as well as on the Intel Galileo, it comes in the form of Yocto Linux. So Intel Galileo development board is also using Linux operating systems. There are many other operating systems which are being used in most of the implementation like Contiki, Riot, Embed, etc. Okay, coming to the development tools. See, writing the programs for this IoT devices, IoT microcontrollers, and then uploading it on the device. Like for this, we need specialized tools. And this is specialized tools are called IDEs. IDEs stand for Integrated Development Environment. It's a single environment in which all the development tools necessary to write your program, to test your program, to simulate it if needed, as well as to debug your program. All these tools, it means compiler, assembler, debugger, all the tools are integrated in a single environment. So IDEs today's IDEs are very feature-rich IDEs, and this IDEs supports or let's say makes the life of the developer easier. Uh, the first IDE that is being shown here is Microvision 3 from a company called Kill, and this IDE is used for writing software for 8051 family microcontrollers, as well as for ARM-based 32-bit microcontroller families. Okay. The second IDE that is being shown here is Arduino, the most very popular Arduino IDE. This IDE is very easy to use. It comes only with 5 buttons. You can very easily write your program and upload it directly on the microcontrollers. It is. The third IDE that is being shown is PyCharm. It's an IDE for writing software for Python. There are many other IDEs used by the Python developer depending on the application domain. So there is one IDE called vPython or Bidle. There is one called IDLE Idle. Idle is a very simple IDE, and on Raspberry Pi platforms we use IDLE Idle to write Python programs. The second IDE is Vidal. Vidal is actually visual Python IDE. So with the help of Vidal, you can develop lots of graphical applications. The third IDE that is being used by the scientists nowadays is called IPython. IPython Notebook. So IPython notebooks provides lots of facilities to document the code and then publishing it in the form of HTML documents, as well as you can share with other people in the form of presentations. Uh, there is one more Python IDE called JRib. So Jerinth is actually going to support Python, writing Python applications for high-end microcontroller platforms like Arduino or for Odoo. Odoo is a platform which supports Linux as well as Android, as well as many other high-end prototyping development boards which are being used in most of the IoT implementation nowadays. Jerinth, which was earlier Viper, now it is called Jerinth, is a very popular IDE being used to develop high-end IoT applications. Okay. Uh, IoT, the IDE used by Intel Galileo platform is a very popular IDE from Intel called Intel XDK IoT Edition. So this, with the help of this Intel XDK IoT Edition IDE, we can program Intel Galileo board uh, through a network, or let's say wirelessly. So we can upload the application directly on the Intel Galileo platform with the help of this IDE, either through a wired network or on the air too, like by using Wi-Fi connection. Okay. So these are the basic IDE or popular IDEs being used to develop IoT applications. Okay. The use cases of IoT. Okay, IoT is everywhere. It's everywhere. We are surrounded by it. So all the smart city projects, the backbone of smart city projects or connected cities projects all around the world is IoT. The connected cars, nowadays, it is expected that by 2020, 90% cars are going to be internet enabled or connected cars. And these connected cars, the manufacturer as well as the service centers are connected to these cars in real time, and they're able to diagnose, or let's say they're able to repair uh, everything on the air or through the internet. So by 2020, it is expected that there are going to be almost all the cars are going to be internet enabled. Now, when it comes to connected health, like most of the hospitals or healthcare providers are using wearables to collect health data from the patients, so that a patient is connected to the hospital 24/7, or let's say real time monitoring is being managed by using IoT technology. In the industry, like most of the processes are now automated, and everything is managed by the IoT. The connected energy, uh, energy management, energy distribution management, water distribution, everything is managed by the IoT. So you can see in this slide that almost all the aspects of our daily life is being touched by the IoT now. It's everywhere. Okay. Smart city is all. I've already discussed. Smart city is one of the potential application of IoT. Smart farming, in which farmer is able to uh, manage its work through internet. Uh, Smart healthcare delivery, in which patients are connected to the healthcare delivery systems in real time, and all the data is being collected. Health data is being collected from the patient in the form of wearables. So wearable is going to be a huge market, as well as IoT is being used in home automation domain too. Okay. Smart connected cars is already discussed. The connected car is a huge market for internet for IoT. Okay. Now, when it comes to overall market of IoT worldwide, you know, there is a world market of around 11 trillion dollars. It means this, or according to Cisco, the world market, there is a world market of 19 trillion dollar by 2020. It means there is a trillion-dollar economy, and this trillion-dollar market, IoT market, is going to generate billions of jobs for the engineering, for engineering graduates. Now, when it comes to working in this domain, IoT domain, the skill set that is needed is that a person has to be has to have very good understanding of electronic systems, electronic components, the selection of electronic components, designing electronic circuits, as well as testing these electronic circuits, a good knowledge of soldering, desoldering of the electronic components, plus a sound knowledge of programming languages, operating systems, and the communication technologies is also desirable. So the right skill set to work in this domain is a very sound knowledge of electronic technologies, electronics, as well as basic fundamentals of electrical engineering. At second level, a person has to be good with programming languages. Third level, a person has to be good with the communication technologies, and at the topmost level, a person should be having a good knowledge of cloud computing as well as analytics. So with this, I'll conclude my presentation here. If there is any queries or doubts or questions, please feel free to ask.